So we're going to talk about the difference between something being statistically significant or practically important. So statistically significant is when the p-value, that is to say the probability of seeing the result that occurred, is less than alpha. That's my significance level. Now alpha is typically that 5%. So if anything occurs less frequently than we would expect it to see by random chance, if anything happens less than that 5%, we say it's statistically significant. But is it practically important? So when I say practically important, I mean, is it a big deal? Are we super concerned about the result that we found? To frame this up best, I like to use an example about a certain healing cream ointment. You put it on your cuts and it speeds up the natural healing process. Or so the company would like you to believe. So they went out and they conducted a study. And what they found was that a sample mean heals to the point of no scab after 7.2 days. Well, this was less than the 7.6 days that people tend to heal naturally on their own without the super healing ointment. Now, they found that they had a p-value of 0.04. So the outcome that they had happens only 4% chance randomly. That's below our significance level of 0.05. So they could say, yes, our findings are statistically significant because the probability of the result we saw is less than that threshold of 5%. But is it a big deal? Is it a big deal that your scab falls off at 7.2 days as opposed to 7.6 days? Is that 4/10 of a percent, or 4/10 of a day? Is that truly important? Well, I think there's an argument there that no, it's not a big deal if you're fully healed a half day sooner than you would have been without the super healing ointment cream. So there it is. That's statistical significance versus practical importance. Sure, something might prove itself to be greater than or less than. We might reject a null hypothesis of no change. The ointment is doing something, but is that result, is that impressive enough for us to be truly concerned about it? Is that sped up healing of 1/2 day, is that a big deal? Okay, so that's topic one, comparing those two items. Topic two is looking at just the p-value or the p-value in light of a significance level alpha. So alpha, which is the significance level, or just the p-value. P-value, of course, being the probability of seeing the result that we saw, if all other things were random. So the significance level gives us that threshold where we can safely reject or fail to reject our null hypothesis. So this is the line in the sand. Reject or fail to reject. Whereas just the p-value gives us evidence one way or the other. This is the evidence. The real question lies when we set a significance level of 0.05 and then get a p-value that looks like this? What if the p-value is equal to 0.051? Well, according to our line in the sand, we would have to fail to reject a null hypothesis. But what if we're talking about the cure to some crazy disease? And we get a p-value after testing whether or not our cure is effective. We get a p-value of 0.051. Should we say, well, we failed to reject the null hypothesis, that the cure does nothing compared to its natural state? Or should we take this as evidence that, yes, the cure is doing something, though we may not be as fully confident as we would like to be of its results? So just the p-value shows you evidence towards something happening. Maybe there's an effect here. Is it as much effect as we need to reject our null hypothesis? No, but it's pretty freaking close. If we had an alpha of 10% as our threshold, then we would have said that there's an effect. So be cautious of ones right here on the line. It still indicates that there might be an effect. And I would recommend we investigate further. Okay.